Welcome to my channel. So, today in this session, let us discuss some MCQs in power system analysis. Already we have discussed about the per unit calculation, A-bus calculation, Y-bus calculation using the singular transformation method, inspection method, etc. Relevant to those topics, let us discuss some MCQs which is frequently asked in the case of UPSC, IES examination, Tancet, etc. Right? The first is the per unit impedance of the Z per unit in a three-phase system is the per unit impedance of a Z per unit impedance per unit is given by the formula. It is nothing but Z ohms into MVA by kV square. So that means MVA base divided by the kV square multiplied by the old value of the impedance. Option E is the correct, and check other things. Here in the B it is given as kV square by MVA base, and here it is given by kV base by divided by root 3 IB, and here it is given by 1000 kV base by IB into 10 power 6. So instead all those things, option E is the correct answer for the provided first question, right? And similarly, next is the S per volt is the per unit impedance on the power base. So this is the per unit impedance, and power base is S volt, and the voltage base is VB volt. What would be the per unit volt? These are the volt values. What would be the per unit impedance on the new power base of SB new and the VB new? Actually, the per unit impedance generally we write this as Z per unit volt is equal to MVA Z per unit new, which is equal to MVA new divided by MVA old into kV old by kV new the whole square. So this is the general expression which we write for the calculation of per unit value calculation. So instead of MVA new, here this is given as the SB old and SB, right? With this, the formula for the Z per unit is nothing but Z per unit new, which is equal to Z per unit old into Z per unit by SB new by kV new by VB whole square. This is one form. Our formula is relevant to the option number B. That means Z per new, which is equal to Z per unit old into SB new divided by SB old into VB old by VB new into full square. So, as the formula which we have written already is equivalent. Instead of MPA new, here there is only SB, right? So, the next, if the voltage control bus is treated as the load bus, what is voltage controlled bus? It is nothing but the PV bus. If it is treated as the load bus, what is load bus? It is nothing but an PQ bus, right? Then which one of the following limits would be violated? If voltage control bus is treated as a load bus, then and which of the following limits are violated? Here, active power is violated, right? So, the next question number. In the question number 4, in the network shown, the marked parameters are per unit impedances. The bus admittance of the matrix of network is here a two bus system is shown. So we have a 2 cross 2 matrix, right? And the impedance is calculated as this is the Y bus formula. Y bus is equal to Y11, Y12, Y121 and Y22. And here for Y11, this is the first bus. The impedance of 0.2 and 0.2 are added together, right? As we know already, Y11 which is equal to 1 divided by Z11 plus 1 by Z11. 1, 2. In substituting this formula, we have the answer as option number C, which is minus 10, 5, 5, minus 5. And also off diagonal element y12 which is equal to y21 which is equal to minus of the impedance value, right? Similarly for y22 we have discussed already. So y22 we have the same cases, right? In y22 only 1 divided by z22 is connected and this value is not connected. So we have the option C as the provided two bus system, right? Similarly for the next question. Next is for the sample system given. So this is the sample system and we need to calculate the per unit impedance of the particular element Y22. Here the sample system, it is a 3-bus system and so we have a system as Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. Since it is a 3 cross 3 matrix because of 3 bus system, right? So here instead we need solely the y22 one, okay? And consider the sample system. In the sample system, the bus 2 in which J 0.1 value is connected towards the bus 1, the 2, and this value is connected to bus 2, and similarly this value is also J 0.2. This value is also connected to this, right? So y22 which is equal to 1 divided by z12 plus 1 divided by z23 plus 1 divided by its self-impedance, right? So by substituting the values of z12, z23, z22, we get the option as t which is equal to minus j20. That is 1 divided by j 0.1 plus 1 divided by j 0.2 plus 1 divided by j 0.2. You get the value as, by converting this, you have the value as j minus j20. So option number D is the correct answer for the question number 5. Okay. So the question number 4 and 5 are relevant towards the Viber system. You can expect such kind of the questions for the case of objective type in the case of Tancet, TRB examinations, IES examinations, as well as the UPSC examination, right? And in addition to this, we also discuss another question relevant to the Y-bus formulation. And question number 6 is the network shown in the figure has the impedance in per unit indicated. The diagonal element Y22 of the bus admittance matrix. So the for the bus value of 2, self impedance value is asked. Here already we have discussed the same sort of question in question number 5. In the question number 5, the impedance value are given in the positive cases, right? And by converting this, we obtained one such case, right? Here in the bus number 2, this bus is connected and also this bus is connected. And sorry, this impedance is connected, this impedance is connected, and also this is also connected. And here we convert this as y22 which is equal to 1 divided by z12 plus 1 divided by z13 plus 1 divided by z2, right? And Z12 is J 0.1, Z123 is 1 divided by J 0.1 plus 1 divided by minus j20. If you convert this into the polar form and then into the rectangular form, you obtain the option D as the answer for the question number 6. Right? So, you can expect those kind of questions in the case of writing some more the competitive examination. So be thorough with the case of IBUS calculation and relevant to the instruction method rather than the singular transformation method. If you like this video, like, share and subscribe. Thank you.